Okay, this is spring test number 6 from sections 1-1 through 7-3. Um, we did systems of equations on 7-3, where we did substitution with 7-2, and then combinations to eliminate. We are picking up at number 24 and 25, the last two problems on this last part of the video. This is part 5. We want to graph this inequality. 6x plus 6y is greater than or equal to 14. You need to convert this to a form of an equation that you're comfortable graphing. Again, if you like using intercepts to graph, you can use standard form to graph it, but most of us would rather convert something into slope-intercept form, y equals mx plus b. So in order to do that, you want to get the y term by itself. 6x is not the y term. That needs to go to the other side. So that says 6x or positive 6x. Undo that by subtracting it. And if you do that to the left side, subtract 6x from the right side. What that leaves you with is 6x on the 6y on the left. And all we did was subtract it, so our sign will stay the same. We don't need to flip it. We can't take 14 and subtract 6x from it and get 8x because 14 is not a variable term. All we can do is write these next to each other. Negative 6x, positive 14. The only other thing we got to do, or the last thing we got to do to get it into something we can graph, is get rid of 6 times y by dividing it. If you divide that by 6, make sure you divide this by 6 and this by 6. 6 divided by 6 will give us just y. We divided, but we divided by positive numbers, so you leave it as greater than or equal to. Negative 6 divided by 6 will leave us with negative 1x, or simply negative x. And then 14 over 6, the number 2 goes into both of them. It goes into 14. It goes into 14 7 times and into 6 3 times. So positive 3 over 7. So we have y equals mx plus b now, where our m value is negative 1, and our b value is 7 over 3. Or I wish it would not be a non-integer number, but we're going to have to use it as it is. M's value is always going to be a fraction, so we want to make it be over 1. Let's graph it just like it is on a coordinate plane, on a Cartesian plane. B says 7 over 3. If you convert that to a mixed number, 7 over 3 is 2 and a third. So what you want to do, you want to estimate a little bit when you graph this. If you have 1, 2, 3, 2 and a third will be about a little bit below halfway between 2 and 3. So that's where you're going to want to start it. Your slope still tells you to go up 1 and go to the right 1, so we can still graph the next part. We'll go up 1 and to the right 1. So again, go to about a third over the next one and then to the right 1. So about like so will be your second point. It'll be enough for a visual for us. Remember, greater than or equal to. The or equal to part tells us that we need to draw a solid line, not a dashed line this time. The last one we had to draw a dashed line, but a solid line through it. And then we have to either shade one side of the line or the other. You don't just guess, you actually pick a point and see if it's true or not. Test its truth value. The easiest one to pick is always the origin 0, 0. So plug those numbers in. Remember, the only time you can't use that is if it actually falls on the line. Plug in those numbers. 0 in place of y is greater than or equal to negative 0, because that's in place of x, plus 7 over 3. That leaves you with 0 is greater than or equal to negative 0 plus something, just kind of eliminates itself, 7 over 3. 7 over 3 is a positive number, so it is actually larger than 0. So that means this is a false statement. So it's wrong to shade this side because that's false. You want to shade everything to the other side. That's how your shading should look. And then the last one, number 25, says $7.80 per hour is how many cents per minute. So you have to convert two things. You have to convert dollars to cents, and you have to convert hours to minutes. This is a skill you'll use a ton in your science class, believe it or not. $7.80 per 1 hour is what you have. In order to convert, we'll do, or let me write that actually in black to keep it where we can change them up. Same thing, no, $7.80 per 1 hour. The first conversion we'll do is from dollars to cents. Okay, we have our dollars is at the top of our fraction. So when we do our conversion, we want to make sure we multiply by something that has $1 at the bottom of the fraction, $1. We're going from dollars to cents, so we know there are 100 cents in $1. So that'll make our first conversion. Our second conversion will go from hours to minutes. If we look at the first fraction, we have hours on the bottom of our fraction. So when we multiply by something, we need to make sure we have 1 hour at the top. It has to be, remember, top and bottom have to be opposite each other. And in 1 hour, we know we have 60 minutes. So what we did just now is we eliminated a bunch of unit measures. We eliminate dollars divided by dollars cancels out. We eliminate hours divided by hours cancel out. What we're left with is cents over minutes, and that's exactly what we wanted, cents over minutes. When you multiply straight across 7.8 times 100, all that makes you do is move the decimal over 2 times, and it gives you 780. You don't have to do any calculating, just move your decimal twice, 780. Then multiply 1 times 1 times 60, and you get 780 cents per 60 minutes. So 780 divided by 60 is 13 cents every 1 minute. So it says $7.80 is how many cents a minute? 13 cents a minute.